In the previous lessons, we learned that molarity is represented by the letter M, capitalized letter M. And when we see the capitalized letter M, you kind of have to ignore it. And you have to realize that it's equal to the number of moles A equal to the 1 liter of solution. Well, A is your solute. So the best way to think of capitalized M, always think about this. Number of moles of solute over 1 liter of solution. Always think about this. Okay, so keep that in mind. This is the most important part about molarity. And one last thing you have to remember is this liter of solution right here. In most cases, the volume of the liter of solution is equal to the volume of the solvent because the volume of the solute is too small. It is a solid, but it is extremely small in terms of volume. And in most cases, we would use liter as the unit of measurement. So we have liter of solution equal to liter of solvent. So let's do an example problem to see how we use molarity as a conversion factor. Well, how many moles of HCl, which is hydrochloric acid, are required to make 2 liters of 0.5 molarity of hydrochloric acid? So we know that this right here, see right there, this part right there, is equal to 0.50 mole of HCl over 1 liter of solution. And we can just ignore that part, but now we're going to write at that part. That is our conversion factor. So let's continue to solve this problem using the same strategy before. Take a given time the conversion factor. In this case, our given is 2 liter of solution. So we have 2 liter of solution time our conversion factor. Well, if you notice right here, right, we have to visualize what's happening here. This 2 liter of solution has a molarity or the concentration of 0.5 molarity. So that's the conversion factor. If this is a liter of solution, down here must be liter of solution as well. And how many is it? It is just 1. And what's on top? Well, 0.50 moles of HCl. And that's pretty much it. We get our moles of HCl right here. And look what happened to liter solution. It cancels out. All we have to do now is use a calculator and solve for it. So let's plug in a calculator. Multiply everything on top, divide everything on the bottom. So 2.00 times 0.50. So the same process, multiply everything on top, divide everything on the bottom. 2.00 times 0.50. So 2.00 times 0.50. Divide by 1, which we can ignore, and turn out to be what? 1. And we want to keep 2 decimal places. So in this case, it's going to be 1.00 mole of HCl. And that will be how many mole that we need to use to make 2 liter of solution with 0.5 molarity of HCl. Now let's try another problem to see how the same conversion factor is used in different way. So again, molarity is equal to number of mole A equal to 1 liter solution. Now, how many liter of solvent, okay, which is water in this case, is required to make 1.90 molarity of NaCl solution with 3.5 moles of NaCl? You know right away, this is our given. And we are looking for a liter of solvent. But one thing we learned before is that we can assume that the liter of solution is equal to the liter of solvent. So instead of using the term solvent, we are going to now use liter of solution. This is the one we're going to focus on, okay? So let's look at this and how can we rewrite our conversion factor in terms of this part right here. We have 1.9 molarity of NaCl. Well, that can be best as written as, remember, 1.90 moles of NaCl divided by how many liters of solution? Remember, by definition of molarity, it is always 1 liter of solution. Now, this is our conversion factor. So let's use this and solve it. Well, our given is what? 3.5 moles of NaCl. Time our conversion factor. If this is moles of NaCl, and we look at this, well, the mole is going to be on the bottom, 1.90 mole of NaCl. What's on top going to be? 1 liter of solution. And remember, the liter of solution is equal to the liter of solvent as well. Look what happened to moles of NaCl. It cancels out, give us a liter of solution. And the next step is we just plug this in our calculator. Again, multiply everything on top, divide everything on the bottom. So we have 3.50 times 1 divided by everything on the bottom, which is 1.90. And that turned out to be 1.84. So 1.84 liter of solution, which is equal to 1.84 liter of solvent as well. So either answer will be fine, okay? And that is how we use the conversion factor in a different way.